Okay, so we'll start in
I
like
believe
two
everyone
minutes.
can chat now, sir. Or let me check.
Yeah,
Just put a hi, everyone else. Just want to check if it's a two-way. Yep,
yeah,
great, great. So it's fine now.
cool. Thank you so much.
Thank you, sir. I'll drop off, sir.
Yeah, yeah.
Thank you.
We'll start in 2 minutes, guys.
First,
Meanwhile, any queries from the previous session, please let me know. Happy to address them. And then this session will probably do it at a stretch. We'll have the break at the end, and we'll try to keep that flow for this session. Any questions? Okay, Jyotisma is saying trying Google Finance for Tata Motors, but you're getting an error. So it pulls from Nasdaq, I think. So that's the reason. So if it should be listed in Nasdaq, I can see if Google Finance function can pull any other stock market. Yeah, so you need to put something like this. Yeah, that's the syntax. So it will pull from Nasdaq. If you want, BSE or NSE, then the syntax would be a little different. I'm just seeing what should be the syntax. Okay, ticker. I think it might not be there as well because I'm not getting a direct attribute. And to try using the right symbol, so that is also very important. Yeah, I think it should work. So you need to say NSE colon XXXX. Whatever is the symbol for Tata Motors on and is NSE, mention that. I think you should be able to pull. Okay. Okay. Eunice is saying, hi, well, good evening. Do we have data for this session? Yes, I will share that during the session. So everything will be in Python scripts, and we will be doing a lot of practice exercise and all of that. I'll share you the collab and stuff. So we will do it more collaborative way, like we typically do. Cool. Any other questions before we proceed? Okay, I don't see any questions. Then let's get started. You guys can see my screen, right? Cool. So the next two sessions will focus on Python. It will be more in terms of getting a bit of basics around Python, and I have taken a lot of different courses. I've seen students struggling quite a lot with Python. Especially there'll be a lot of non-tech folks, and for them, Python is like a nightmare. And the major challenges that I know of are first setting of the Python environment, dependencies with libraries. When you have to install, there'll be those certain errors which sometimes never get fixed. Uh, so this environmental setup of Python itself is a big challenge, and that's where a lot of people kind of lose interest on Python. And second thing is, now we are moving to an era where you don't really need to code, right? So if you know the basics and if you know how to stitch the code, uh, Bard or ChatGPT can give you the codes, isn't it? Say if you want to write a program to which is a for loop and a multi-layer for loop, and which does a particular task, you can simply say, "Hey, ChatGPT, write a function to do this job." You'll get the code, and you can simply kind of package it and then stitch it and then do your coursework. So in the next 3 4 years, it's all gonna be a change in how you program. So just if you are able to even understand the basics, and if you are able to get comfortable in using the tool, then you'll be at a much better shape to do a lot of things. Now, second thing, you don't need to program, and without zero programming you can do a lot of Python, uh, I know Python exercises or Python modules, which I'll show you in in the next session. I don't want to show in the first session. So first session will be you to do get your hands dirty, understand the basics, get your foundation strong, understand how these data structures, how does Python as a programming language works, so that how many ever tools you have or modules I show you where without any program you can solve a lot of things. It's very important to understand the fundamentals of Python, how the data structures are, how Python interacts with multiple different objects. So you need to know the overall infrastructure, and that is very important. So today's session will be basics, understanding Python and doing a lot of things. And one major change that you would see is we'll use collaboratory, which is by default present in all your Google Drives. The reason why I recommend that is, you don't have to deal with multiple versions of Python or libraries, and it becomes easy to share between each one of you. So you can easily discuss, collaborate, share solutions, ideas, and if a script is working in anyone's laptop, it is 100% sure it will work in some other's laptop, if it is built on collaboratory. So you don't have to worry about any environment. Is it Windows, Linux, Mac? If you do build it in collaboratory, it works everywhere. So with this, we will get started with Python refresher. And we know the topic I outlined, and let's start with Python and its interface. So how does Python typically work? So Python is actually a programming tool, and that is, it doesn't have a user interface by itself. So Python is actually a program which runs in the backend, and it's accessible by multiple ways. The most easiest way people access is with a black window, which is the terminal. So from terminal, if you just say which Python, you'll get the version of the Python in the black terminal, right? Because that is the core or the native program that is running. Now, what you see day to day is a GUI interface. It's a user interface where you can access Python, which is running in the backend, and the terminal is also a way to kind of invoke your Python instance. Now there's so many types of GUIs. There is Spider. You can use Eclipse. You can use any kind of GUI interface. Now you have Jupyter notebooks. Even Collaboratory is a UI, but in the backend, somewhere the Python instance is running. Or you can use the terminal to kind of access Python to kind of do a lot of different things. So initially people were using these terminals or scripts, or they were using Spider, Eclipse, and these are different user interfaces. But yeah, like in the last 5 to 10 years, there came the discovery of these Jupyter notebooks, which kind of did a lot of game change. Why Jupyter notebooks are so useful? One, you can execute it like a line by line item, and it came into existence because of R. You guys know about R Studio, R as a programming language or statistical language, right? So R is a language which is a line by line execution. It's like a sequential execution. So you can run one line, go to the next line, run it, next line, run it. So it goes very sequentially, and you can easily debug. Okay, in line number 34 or 35, there is a problem. You can simply change that place and then rerun it, and it'll solve for you. So there was this era where R was picking up, and it was able to take over Python. So um it kind of made it necessary that Python should innovate in this space. So Python created this Jupyter notebook, which has all of the functions like R, like every cell can be executed separately, and you can see the result in the previous cell before you execute the next cell, and it has the sequential execution. Point number two, you can see the results right along with each of the cell, and you can write documentation. It has markdown format, so that for readability, or if there's a new person who's coming, he wants to understand what is this piece of code is doing, what is the result, for better readability, for better learning of Python. Jupyter notebooks kind of made it very easy and possible. And that's how Jupyter notebooks kind of became very prominent. And even the collaborative that we are going to use for this mini project, it's going to be in collaborative, and it's a version of Jupyter notebook itself. Okay, any questions so far? Any questions? Okay, 3-second rule. What does this line does? Percentage matplotlib in line. Okay, we'll talk about that. So these are certain command lines to kind of format the output. So these are called magic commands, which basically run behind the scene, and it kind of dumps the object into a nice format. Okay, and then there is one more question. No, just account we had used Anaconda or Jupyter, which while doing earlier project. Very good. So Anaconda is a good way, because what it does is it kind of packages all of the libraries into one single place, and it becomes easier for the issue where dependencies, library versions, it's working fine in one laptop, not working in other. All of those issues will be gone with um Anaconda. So that is good, but still people might feel it's a little more technical to use, or sometimes it not be that intuitive. And so, for example, say you're stuck somewhere. If you want to share your workbook with someone else to fix it, it's very tricky. In collaboratory, 10 people can work on the same notebook. Everyone can collaborate easily, fix it, and everyone is in the same environment. So I still recommend collaboratory. Any other questions? Okay, Jyotisman, is it clear? So basically what it does is, when you inline is along with the code, get the output. Okay, so whenever you do when you put that thing in the top, it's called magic commands. You're basically saying that whatever code you're giving to matplotlib, you're passing, when you're invoking that, the code is along with the output. It's in line with the output. So it will be below the code cell. All of the plotting commands, everything will get displayed. So that's what it does. Okay, so if all this is clear, let's go ahead. Okay, so Jupyter Notebook. Um, so this I think everyone is aware of and how this works. Installation, I think you might have already done. You use Anaconda, and then you say pip3 install Jupyter, and kind of it configures everything and stuff, right? Like, and then you can say new Python 3 workbook, and that creates a new workbook for you to execute. And then you'll have different cells, and then you can use a code cell or a markdown cell. So markdown cell you typically use for any kind of documentation. Code cell is where you write the Python script. This is like a simple hello world. That's how you can start. And you can even kind of give a pause between the next cell execution by using the time command. And you can create a function, and you can call the function here. So that's how you can do. There are different keyboard shortcuts for different edit mode and a command mode. And for markdown, you can use single hash, double hash. Single hash is level 1 heading, double hash is level 2 heading. And if you want to give bold, you can do this is kind of a syntax. Or if you want to italicize, then you can use something like this. Then the text inside that format will be in italics, and paragraphs must separate by an empty line. Sometimes you want lists, or which you want some bullets, then you can use asterisks, and you can still be able to get the output. Okay, so this is level 2, level 1, level 2 heading, and you can see how you can format your data using a markdown format. Now kernels. So kernel is basically that shell of where the Python instance is running. So whatever code you write in the Jupyter notebook, that gets executed within that kernel, and output comes back to the cell, and it will be displayed in the UI. And the kernel state persists between cells, as in the instance is one, and when you connect, the instance will be there until the session overall session is active. So kernels is nothing but think about is like one single Python instance. So you're opening the terminal and then writing one code after the other. So it's one terminal instance which is getting accessed or invoked from the UI. Any questions so far? Because this is like very fundamental into understand how Jupyter Notebook works, where is Python running in the backend, and without this understanding, you'll not be able to enjoy this programming language. Okay, so I don't see any questions, and then let's proceed. Okay, we saw about kernels, so that's about it. And naming workbooks and all of that, that's fine. Okay, now what we will do is I'm sharing a workbook. Can you all open this workbook? Is the workbook accessible? Yes. Okay, there is some issue. Let me try to connect this. Okay, getting this notebook loading error. There was an error trying to load. Ensure. Okay, 1 second. Then let me fix it in a minute. That's pretty strange. Okay, hold on. Okay. Then that's okay. Don't bother that much. I am going to error for signing, right? Yeah. Ignore that. What we'll do is I will share you another workbook. Yeah, I'm sharing another notebook. Are you able to use that? Is that working fine? Yes. Okay, perfect. Then let me reshare. Okay. Now you should be able to see the screen. Okay, good. Now we have everything handy. Yes, good. Okay, got intro page. Perfect. Okay, fine. So we okay, keep that handy, and um, this essentially helps us to we can create any new notebook. This is how the collaboratory works, and the beauty is that you can share. I if I get this link, I can share with any one of you, and you can make a copy of this, run it, and then easily do any kind of work that you want to do. So there's different things like data science, machine learning. These are all like introductory things which is present, and all of this can run. Okay, so let me remove this and open an empty one, and let me call it as session one. Session one. Okay. So this is how you can rename the notebook. You can add it as favorites. You can share with folks. So I can say anyone with the link, and I can say editor. And if I copy the link and I give it to you, we all can practice uh, using this link. Not able to see your screen. Okay, that is strange. I reshared it just now. Okay, 1 second, 1 second. I think it's asking for some browser access. Okay, this is now 1 second. Please get browser access to screen recording. Just a minute. Give me a minute. I'm trying to fix it. Okay, done. 1 second. Now it should work. Okay, perfect. Okay, now it should work. No, it's not happening. So that's okay. Then I'll find a solution. Don't worry. 1 second. Then we will not use this for today's session. Okay. So there are multiple browsers in my laptop, and essentially one version of the browser is not working well to do the demo. So that's okay. Now you should be able to see. So you're able to see my screen, right? You're able to see the presentation, and this is how a Jupyter notebook looks like. And let me call this as session one, and I'm connecting to a runtime. You're able to see the screen? Yes, all okay. And I and we Okay, perfect. Good. Okay, so this is the collaboratory. You can rename it. Then you can share with multiple people. And then I connected it to the a Python Google. If you see Python Google Compute backend, it got connected to that. There is RAM and disk available for this. So you can make it a favorite, and you can start writing the code. So if I say a equal to 5, enter it. And if I say a, the context in the previous cell is present in the next cell. So it's one single instance. When you connect to our in particular instance, it keeps that instance running for the entire duration. So that's how this is gonna work. Uh, and on the left you have different folders, and you can see some sample data. So if you don't have, you can create a folder, and then you can add new data sets so that you can use it for any kind of analysis. So you kind of need to upload. So you can say file, upload, and whatever CSV files you have, you can add it here, and then you can reference this by this path. Say if I say copy path, so this is the path. So read.csv, and if you enter this path, then it will automatically read the files that you uploaded here. And that's how you kind of can use collaboratory, and all of the flat files that you receive for your Capstone project, you can simply upload it, and you can reference the file path. Once you create a pandas datasets, it's all the same. And you can see all of the variables that you create here. So if you see, there's one variable that was created, right? A. So it is showing that you can filter, and you can kind of when you want the values to be displayed. And this is like if you want to find some code and replace it, you can do this. This is like a table of content, so you can create some sections so that you can improve the readability of the code, right? So and you can name it. So this is like basics of Python. So that's how you can kind of create sections, and then you can use it, and you can create new cells and all of that uh, very easily. So you can create multiple sections and you can start improve the overall readability. Okay, next. If you want to create a new cell, you can say B, uh, click outside and click on B, that will create a new cell. Or if you click A, it will create a cell before that. So that's how you kind of create cells. Um, can you all write a small function, a hello world, to kind of print hello world? Can you open collaboratory? And what we will do is we can see if you are able to. Everyone can write their copy paste the scripts here in the chat window. Like, we need to use the third link, right? Actually, you can, yeah, you can use that. I can share the link. I just need a simple script. You can paste in the command prompt in the chat window. What is the line command to kind of enter? Okay, great. Eunice has written a very simple command. Jyotisman has also done it. Okay, let me copy one of yours. Perfect, working well. And then great. Hello world. Perfect. So you're able to get the result, right? You're writing something, you're executing it, you're connecting, you're using Collabority to do all of that. Perfect. Okay. So then we are good to proceed further. Okay. Now we will see how you can use Jupyter notebooks for doing different data science activities. So there are multitude of things in data science that Python can help, right? So data, so in any data science problem, first is obtaining the data handling in terms of like merging, transpose, roll up, aggregate, joining, and then third is exploratory data analysis and quality check of the data. Then comes modeling, predictive modeling, and then comes insights or generating insights, and so on and so forth. So this is like a sequential set of things that happens in data science, and Python helps in every stage of this. So this is one other article I would encourage you to kind of go through this Jupyter notebook and how it overall helps. Probably let me play few. So go to this video. Okay, I don't want you to view this in this session, but go through this. It tells you an introduction around how to import the libraries, and then line by line from the command prompt, you can see how the chart is coming up, and then it talks about Jupyter Notebook, how you can run the cells. So pretty basic, but you'll be able to understand from the terminal versus from Jupyter Notebook how does it work. So yeah, now let's go to NumPy and Pandas. So we'll be using this scripts from here. This is a good, nice compilation of all the functions for NumPy and Pandas. So NumPy is essentially a library to kind of handle numbers in a more scientific way, and this is very critical for all of the data science kind of data manipulations that we do. So import NumPy as NP, and you have a list, and you're creating an array. So when you say list one is 1 2 3, what happens is a list object is getting created, and it is having three elements. So list is kind of a data structure where you can have both numeric and string data together. But if you want to do any kind of operations, arrays are more preferred. So that's why we are creating a array, and then we are converting list one, which is a list data type, by using np.array. So NumPy gives you that data conversion features to convert a list into an array. So this is how you can get an array. Then if you want to check the data type, you can say type of list one, and then this will give a list as an output. And type of array one is an numpy.nd array. So this is a numpy's data type. So if some other library might have its own data, but this is a numpy nd array. So that's one difference. And I'm creating another list, and I'm kind of converting it to an array. And then you can add two lists by saying list one plus list two. That would kind of combine both of these together, and you'll get one single consolidated set of all of the elements together. Okay. So can you guys create two lists and then join them together? You can use the scripts from here and then paste it in the chat window. Please share the GitHub link. Yes. I'm actually sharing the presentation link. This you should already have. The presentation will have all of the links that we're talking today. But I would recommend not to use this. Try to do it yourself. And I can do it parallelly. Import numpy as np and say list one is 1 2 3, and array one is equal to np dot array. And you'll get all of these examples. See, a numpy dot array of list one. Okay, I want first you guys to complete it. Then I can do it. So I did it almost. So you simply has to create list two, array two, then say array one plus array two, and then that's it. You can put everything in one single line. And I can create list two. Then array one plus array two. That's it. So what, okay. Could not broadcast together because of different shapes. Array one plus array two, because it was two different shapes, it wasn't working. And now it's fine. Okay. So you should combine any two arrays, and then you should be good. I'll give like a couple of minutes. Okay, I can see Jyotisman doing it. Rahul, great. We can just add two lists. Is it mandatory to convert to array? And you understood the problem. Okay, great. So if you add to lists, so what's happening? Let's see that. So list one plus list two. What is happening here and what is happening here? Try to understand that. So in an array, it sums the elements, but in a list, it's a simple um, kind of adding into a basket. So suppose if I change this will throw an error, but this will work because list is simply adding it to a basket. Okay, is it done by everyone? Did you all get this? Okay, I can see Jyotisman output. Yes, looks great. Nilesh, great, cool. Okay, now let's proceed with the next task. Mathematical operations with the numpy arrays. So if you want to print a multiplication of these two, when you're multiplying these two, the elements get multiplied, and division, the elements get divided. And even when you put double star, it means taking to the power. So the second element will be the power of the first element. So you're getting the outputs based on this. You can even say np dot sine, np dot log, log 10, log 2, exponential, np dot exponential. Even you can get e to the power of any of the elements. So, and whatever function you have, it gets applied to each and every element in the array. So that's how it kind of differs. Is this clear? Okay, can you do log 10 to the array and share the command? I need log 10, np.log10. Okay, is it done? Okay, I can see Eunice. Perfect. Okay, the output from Eunice is fine. Okay, thank you, Jyotis man. Cool. Okay. Now let's move to the next one. How do you generate arrays easily? So you would want a null array or an empty array to be created so that you can do your execution so smoothly. All right. So for example, there is a point where you need to start collecting the sum, and then you'll use that empty array in the next iteration to add the next set of values. So you need to create empty arrays or np dot ones where you have one 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 everywhere, right? So So it's very straightforward. You can simply say np dot zeros and say 7, then it kind of creates the output like this. You'll have 7 zeros in an empty this, like this can be called as an like a zero, as the 7 elements of zeros in an array. Similarly, you can add ones, or you can get a series of numbers like from 5 to 16, or no numbers spaced by 2. You can create something like this, or numbers spaced apart by a float. Then you can say, so by float is like 0 to 11, 2.5 is the step. So it will kind of get those many elements with whatever step that you have in mind. If you want in a reverse order, you can say 32 minus 1 minus 5 is the kind of a decrease that we want to see. And if you want 11 linearly spaced numbers, 1 to 5, 1 comma 5 comma 11. So this will basically break these two to those 11 equally spaced numbers. Okay, so can you guys create a reverse order with from 40 to 20 with a step of 3? I want a reverse order. So this is the problem. Reverse order from 40 to 20 with a step down of 3. Let's see who can solve this. Okay, Rahul gave the answer. One more answer, and then we'll move ahead. Okay, let's move ahead. Multi-dimensional arrays. So multi-dimensional arrays are like 2-dimensional, 3-dimensional arrays. It's like a matrix. So this is the row, this is the second row, and this is the third row. And each row is separated by a comma. So you can visualize this in this format. So 3 rows kind of stacked on one after the other. And this is a matrix, and you can kind of convert it into an array, and then you can print and then see this is how the array matrix looks like. Okay, now the three important things that you should be aware of when you're working with arrays. One is dimension, other is shape, and then size. So dimension basically says, is it a 2-dimensional array, 3-dimensional array? Of a 3-dimensional is something you might it be difficult to visualize here, but it will be having a third dimension that you'll be you will be able to um, put your data in a 3D structure. For example, if you're talking about an JPEG image, it'll have red, blue, green as 3 different channels. Those 3 channels you can put as a 3-dimensional array. Now, size of the matrix is total number of elements that you have. Shape of the matrix is how many rows and columns are present in the data set. Data type is, whether it contains integers or it contains floats or it contains strings, whatever it is, that's the overall data type of the matrix. Next, zeros, ones, random, and identity matrices. So this is how you create zeros. I think we saw this, and you can even create an identity matrix like this, and you can see how the output is kind of coming together. Next, any questions before we move ahead? Nilesh Tiwari is asking how to do reverse. So reverse is nothing but you the step that you mentioned as negative. So -5 will do the reverse. So first you give the high number, then the smallest number, and then the step should be with a negative. -5, it's basically saying that go in a reverse order. Okay. Any other questions? Any other questions, anyone? Okay. Reshaping, ravel, min, max, sorting. So reshape is essentially changing the shape of it. So how many rows and columns you have, you're changing the shape of that. Say suppose you're creating a random, getting a random number, and then if you reshape this, and C is again you're reshaping as like 6 comma 5. So you hear what you're getting is you're generating a random number, right? So A will look like something like this, 30 different random numbers. And here when you say 2 3 5, 2 into 3 6, 6 5 are 30. So it's a three-dimensional array, and you can see how this looks. So two different matrices which are 3 by 5. So 3 rows and 5 columns. So that's how B looks like. And C is like 6 comma 5. So 6 5 are 30 elements. So the same data you can see how after reshape is essentially looking like. And you can use Ravel to kind of flatten it and then get the output. So you can do this. Indexing and slicing. So what indexing can do is fetching a particular element from the array is very important to do some kind of any kind of analysis, right? So these are different methods. So if you want to get seventh index or from three to fifth index, or if you want to get the last and then in a backward manner, there are different ways that you can access. And even for a matrix, you can say matrix of 1 comma 2 or 1 and 2, or first or second column, something like this. So these are different ways to kind of get a particular slice of the matrix or a particular indexed matrix. Okay, so we'll go to conditional subsetting after a 15 minutes break. I want you guys to practice indexing and reshape uh, these two, and then share your outputs with me in the chat window. Okay, we'll meet in 15 minutes. Thank you, guys. Okay, welcome back, guys. Let's resume with the session. Okay, I hope you guys did the reshaping, ravel, and the indexing and slicing. We'll move to conditional subsetting. So, conditional subsetting is essentially a way to obtain the relevant elements from a matrix or an array. So this is something. Let's say, for example, you have a matrix which has these many elements, and you want only those elements which are greater than 50 to be outputted. So how you can do this is first passing a true false vector and then multiplying a true false vector with this will give you the output. So to get a true false vector, you you can simply say matrix is it greater than 50. So what this is going to do is it's going to multiply each one with this equation. So okay, 17 greater than 50, false, false, false. So you're going getting a true false vector, and when you multiply this with the original matrix, then you'll get your array with only those elements which are greater than 50, and whichever are zero, whichever elements are less than will be just replaced with zero. So this is called conditional subsetting. Okay, any questions on this before we move ahead? Okay, I don't see any questions. Let's move ahead. Array operations. So these are essentially kind of, addition, subtraction, or division, or linear combination. All the kind of operations that we do on array are definitely possible. So suppose you have matrix 1, matrix 2, and addition can be simply done by mat 1 plus mat 2. This is multiplication. This is how you can do a simple division. You can even do a linear combination. 3 times of matrix 1 minus 2 times of matrix 2. This will give you a simple matrix, something like this. And then you can add a scalar, you can do an exponential, or you can do a square root as well. Okay, so this kind of wraps up about NumPy, and then we now move to pandas. Any questions so far? um, Okay, Eunice is asking the slicing part if you could show again. Okay, let me just quickly go back to slicing. Okay, so in slicing, essentially, you can get a particular element from the data, from the array. So suppose this is your array, right? You have 0 to 10, and if you want to get the seventh index, you will say array of 7, and that will get you the seventh element. And why you're getting 7? Because the array index starts from 0. A array of 0 will be the first element. So seventh will be the eighth element, and that's why you're getting the output as 7. And suppose you want third to fifth element, you can put 3 colon 6. The last the last sixth element will not be returned. So only the first element is included, the last element is not included in the output. Okay, if you want to get up to, then you can simply say colon 4. It will get all of the initial until 4. And elements from last backwards are. So what does this do? So this essentially reverses the entire series. So if you say -1 double colon -1, so what is essentially doing is, this is kind of a syntax. If you want to reverse the array, so from 10 to 0, the entire array is getting reversed, and three elements from backwards. So you want three elements from backwards. So three elements from last backwards are, but I think here they want also a step of -2. So so suppose you want output 10, 8, and 6. So -1 colon basically says that this is the last element. -1 basically represents the last element until -6. Until 6, you kind of traverse in a backward direction and with a step of 2. So that's why 10, 8, 6 is what you're seeing as an output. So is this clear, Eunice? This is how you kind of slice it and you can get it. Okay, cool. Any other questions in NumPy before we move to pandas? Okay, I don't see any other questions from anyone. So let's move to pandas. Okay, so pandas is an amazing library because in data science we all work on um, rows and columns like an Excel file or a table, right? So SQL is has become very popular because of its table structure and the ease with which you can access different rows and columns of the table very easily in SQL. So similarly, in pandas kind of helps you to access those rows and columns quite effectively. So it is called in pandas. It calls the object as a data frame, and you can have labels. And say suppose this is your data, and these are your labels, and you can kind of add to the data all of the labels, or you can even get it like a dictionary format. So so this is how a dictionary would look like. So dictionary is essentially key value pairs. So you'll have a key and a value, key and a value. So this is called a dictionary data type. Okay. So say now, how do you convert into a series? So simply say pd.series, whatever data is like 10, 20, 30. This is an say this is a simple list, and you're converting that into a series 10, 20, 30. Right? So this is how you can create a dummy pandas data frame. Okay, can you guys create a data frame with any three elements and quickly share your scripts in the chat window? Okay, then let's proceed. I don't see any response. Then, yeah, let's assume you guys are practicing it side by side, and I'll just proceed. So this is a second data frame with the same data, and you are able to get it, and then you can add. Suppose this S3 with the same data set. So you can create multiple series with all of the different data types, and you'll be able to get the output. So even if it is a dictionary, you can convert it into a data frame, even if it's an array or if it's a list, you should be able to convert it. Next, pandas data frame. So this is how it looks. So you'll have column labels, and these are row labels, A, B, C, D, E. That is the row label. And this is how the data looks like. This is like a matrix. And now you can even create data with a CSV file. So you can simply say pd dot read underscore CSV and the path, and the data frame can get created. And the most useful function is dot head. So if you want to, if you input any data set, the first and foremost thing that you need to do is kind of say df dot head, and then look into the top few records to see how is your data, is the input happening accurately, is it reliable or not, right? So this is a very uh, useful function. So this is to kind of import another Excel file. So if you have a downloaded Excel file and you want to import into Python, then you can use read underscore Excel. Okay. And apart from that, for checking the data frames, you have head, tail, sample, info, and describe. So head gives you first few records, tail gives you last bottom few records, sample gets a random sample, info gives different column properties, data set, and then info gives a summary of the about that particular data frame. And then you have you can even do transpose on describe, that will give you 25 percentile, 50, 75%, and the max. Okay, so let's do one thing. Let's practice these functions on a particular data frame. Okay, so I can see Jyotisman already done that. Can you do head, tail, sample, info, and describe on any data frame? Say let's use this import pandas as PD and then run this. So essentially now we got df2, and if I say df2 dot head of 5, so this is giving the first 5 records, and even you can do same df2 dot tail, so use the bottom 5, and you also have options to kind of visualize this. So you're able to see distributions, values, a time series chart for any data frame in a click. And this kind of shows you the raw data as rows and columns like an Excel file. So that's what this thing shows, and this is like a more detailed analysis with different charts and stuff. Okay, now I'll give you some more time to kind of do this, and then let's see df2.info. Okay, so that's how you can invoke different functions to understand the data set. Okay, can you all do this? Okay, I can even share the script in the chat window here. You can copy the script from this GitHub file which I shared, and you can practice. So if you are able to execute these commands, can you put in the chat window? Okay, Eunice has done it, I think. Perfect. Okay. Okay, I'll give another minute to execute this. Is it done? Is anyone facing any error? Okay, then let's proceed. Okay, data frame can be created from CSV Excel file. We have seen this. Let's move on. Basic descriptive statistics. So on the data frame, you can do a lot of different statistics like mean, standard deviation, variance, min, max. Simply from the data frame, just do dot mean. That will give you mean for all of the columns. You can do dot standard deviation, but the thing is you will get only for integer variable columns. But if you have like a string column, then some of the things might not work. Similarly for variance and minimum, you can do all of that. Now, how to do indexing and slicing for a data frame? So you can, how we have access for array, it is very similar, but in a data frame you kind of do it a bit differently. So to get a particular column, you need to write the column label in quotes and pass it in square brackets for a data frame. So this will get you only the name column as the output. And if you say type of the column, this is a Panda series, core series. And if you want a name and weight, then you can simply invoke in this format. If you want to get the pair of columns, then name and weight you can simply pass, and you'll be able to get the output. Um Yeah, and I think these are similar. Like if you want to get a particular position, a particular index, then you need to reference that particular thing and then get the output. So this will give you the C column. If you want to get multiple rows, and if you want to get a particular uh, uh, element in a data frame, then you can use dot iloc, and this can get fetch multiple rows. So this is to fetch a particular row. If you want multiple rows, you can get it in this format. Okay. Can you guys get the fifth row from your data set? Okay, let's get second row because probably your data set might be small. This is the function that you have to use. Okay, I'll give you like a couple of minutes to solve this. Okay, I can see Jyotisman has already shared the solution. That's right. So if you want to get the fifth row in your data frame, you can use iLock and then just fetch it. Okay, cool. Conditional subsetting. Say you want only specific rows or elements or columns. It's the same logic that we saw for an array. First, get a generate a true false vector, and then you kind of pass it or multiply it with the original data set, and then you'll get the output. So only height get a 155, then you get a true false. And when you put that true false vector inside a data frame, then the output would be only those rows would get printed. So in the like 345 is true, so that's why 345 is getting outputted here. Next, which student might have highest height more than 155 and weight less? So this is called you can use a boolean operator ampersand, and when height is greater than this and weight is less than this, and so on and so forth, and that will get you the relevant fields. Okay, operation specific columns and rows. You can even get an standard deviation. You can get the max minus min for a particular column, get a range, you can get a percentile, and different conditions you can put to kind of filter the data. Okay, and you can even get saying that particular signals in the data should be at a particular limit, then you can pass it and then still move ahead. Okay, any questions so far? Any questions before we move ahead? Okay, I don't see any questions, then let's move ahead. Create a new column and a function on existing column. So you can simply say BMI is a new column that is a formula with weight and height. Then you can simply write the formula and your BMI will get computed. If you want to sort the data, then you can say dot sort values by which variable that you have newly created. You can simply use it. And there is a very cool and useful attribute called in place equal to 2. So what this does is it replaces your original raw data whenever you use in place equal to 2. And with that, we have done the basics of pandas. Any questions before we proceed? Okay, I don't see any questions. Then let's proceed. Okay, this is basically matplotlib a C1 libraries. So this is essentially if you want to build charts on using Python, and says for example scatter plot. You can use age and height to plot it, and you can get a nice chart plot. Then if you want to change format the chart, then it's a lengthy process. Like if you want some bells and font sizes, x-axis, y-axis, grid lines, and so on and so forth, then you need to do all of this uh, quite easy. It's a bit easy if you once you kind of get used to this. It's something like plotting the grid, the y-axis limit, secondary y, then using a scatter plot, some alternate text in case it's not able to find the data, and that's it. So this is how it would look. Similarly for bar chart, it's a few lines. First the size of the chart, then you'll say the weight and the height, how is it, people, and then weight in the kgs. So you might get an output with kilograms, and then you can use that. This is for histogram, simple line chart, and this is for a box plot. Yeah, any questions before we move to a box plot? There's a question from Jyotish Mansar. Can you show examples of in place equal to true? How to do the angle labeling in x-axis? Okay, let me show you in place equal to true first. Okay. Uh, Say for example, you have the data df4 dot sort values by BMI, right? So this is your raw data. Now after sorting, this is the output, but this is only the visible output. But when you do df4 only, then still the data is in this format. But whereas if you say in place equal to true, when you access df4, the original raw data is also sorted. So if you see, it's already sorted, right? So in place equal to true, what it does is it kind of replaces the original data as well. So you don't have to do it again and again. uh, yeah, so this is sometimes useful. Sometimes what happens is your data gets overridden all the time, and you'll not be able to track what changed, is your logic correct, and all of those issues. But typically now it's all okay. And then how to do angle labeling in x-axis. Okay, that's a very nice question. So to do an angle labeling, uh, it's not any difficult. It's about see, if you see adding a vertical line, x, y, and y max you have, and you have line type is dashed, and similarly here you can add, and you will be able to get it. So these are all different uh, constants that you can vary, so that you can get the chart of your liking and interest. Okay, any questions? Okay, I don't see any questions, then let's proceed. Okay, so we saw basics of matplotlib, and then a bit of Seaborn. Let's see. So matplotlib is essentially for plotting. So we saw we were seeing this, right? So let's see pandas operations and advanced pandas. Yeah, so let's talk about little more advanced features. So this is like for reading an Excel file, and df.drop, which will drop you a few columns. Df dot will give you the shape. Subset will give you a subset from the entire data set, like what kind of output you would want. And then you have a box prompt. What it does is it'll get kind of fetch the IQR range, and if anything is falling out, it kind of removes it from appraisal or taking a look into the data. So that's pretty much around the box plot chart. Any questions so far before we move into conditional selections and filtering? Okay, let's take a quick 5 minutes break and then resume back, and then we'll do conditional selecting, and then with that, uh, we'll be like 10-15 minutes more to complete today's session. Yeah, let's take a quick 5 minutes break. Okay, welcome back from a quick break, and let's do conditional selection and filtering. So, conditional selection is essentially only if you want a selected set of fields from the data. You can do that. Say, for example, you want to filter only three set of columns. Then you can pass it as an array like this. So you can say, I want ship mode, state, and sales in the columns. So the first field in your in the lock function is rows, and the second attribute is columns. So I'm basically saying in the columns only these three should be filtered, and in the rows this is a range between 1 to 10. So first 10 rows for these three columns. So that's the output that you can see. So this is how you can basically use conditional filtering. You can pass a range and then have limited set of columns that you want to get an output. And you can even subset uh, by passing a particular, saying that okay, df of subset of sales greater than 100, this will give a true false vector. And that when you pass with this, only those rows where the sales is greater than 100 will get outputted. And say you can use even boolean operators. So only when state is not equal to California and sales is greater than 100, in these two criteria both are satisfied, only filter then. So you'll get a true false vector for this, and when you add that true false vector to another true false vector, the net true false vector output is what you can use to filter the subset, and you'll get the output like this. So this is how you can use subsetting to kind of get an output. Then setting and resetting of the index. So the index is how in your data frame different rows are organized. Say suppose this is your matrix, your row labels and everything. You can convert that matrix into a data frame. So you'll have age, height, and weight, and the row labels, right? So, but here if you see the name of the row names is A, B, C, D. But if you want to kind of reset the index, so I can say df1 dot reset index. So what this does is it resets the index, and you'll get the index as 0, 1, 2, 3, 4, and index will be like A, B, C, D, E, and you have the row names. Okay, just give me a second. Okay, somebody was at the door. Okay, cool. Okay, this after you reset the index, then you basically get a new column for the row label, which will start from 0, and you are able to reset it. And then you can, after, if you say reset index with drop equal to true, the old index will be dropped, and you will get the output like this. And if you want to add a new column, you can simply say df of profession. So this is suppose a new column, and you want to add different elements to it. Then you can simply add like this. And you can even you can set index with as a particular column. You can change it to index. So suppose this is your column, profession with student, teacher, so and so, and you can make this as your index. So all of your index changing is very much possible. You can set your index, you can reset your index, change it. Essentially, this way, how you uniquely identify a row in your data is definitely possible. Any questions in this before we move to the group by method? Okay, I don't see any queries. Then let's move ahead. Okay, the next next interesting field is group by. So this is something that we do. This is like similar to how we use pivot table. In Python you can use group by. So group by essentially aggregates the data by those fields. Suppose this is your subset of the data set. What you do is you basically get only a few records. Say suppose this is the data. Now you can say, after you get the subset, you can group by the state, and then it basically tells you by state what is the sum of sales. So you can say by state, just give me the mean of sales. You'll be able to get uh, by the group by values of a particular column easily. And if you say um, mean and sum, you can even get all of the min max kind of arithmetic computations on the data set quite easily. Okay, I think this is all straightforward in terms of like using describe to take a look at the data. Yeah, so group by two different columns. Say suppose you have state and city, you want for each of these two combinations a group by, you can even do that. So it will break down by state and column, and you will get all of the uh, um, describe attributes like count, mean, standard deviation, and all of this. So you can see the output. And you can also get the missing data. So missing values in Python, say wherever dot is null, if you pass this function, then wherever there is a null, you'll get a true false vector. Now this you can pass to the original one, and then you can say whether a particular field or a row is missing or not. And to fill a missing value with some value, you can use a function called fill na. So you can say the data frame dot fill na and the string that you want to fill. So if you see wherever there is an na, it is adding fill with the keyword, because that's what we kind of pass as an attribute for fill na. And similarly, if you want to subset, you can even do this, and you can continuously use the dot fill na function to replace your data set. Okay. Now dropping missing values, you can simply say def underscore missing dot drop na access one. So by that column, whenever if any of the row is there is a missing value, that will drop that entire row. So that's what drop na does. Okay. Next, outlier detection and simple statistical test. So outlier is something like 99 percentile and above. If we see something very far off, then we kind of drop it. So good way is to draw a box plot and see the how far. So these two are definitely outliers, and then these two also look a lot more of outliers, right? So draw the box plot, see what is the value. Now you can see from the chart, like, okay, 600 mo we have to remove. So you use this as a hard constraint and then simply remove them. Okay, any questions so far? Okay, I don't see any questions, then let's move forward. Concatenation. So you can combine multiple columns uh, quite easy. You can simply say pd.concat df1 2 3 by axis 0. So it essentially appends and concatenates all of the data. If you say axis 1, it'll add by as new columns into the data set. So you need to specify the axis correctly for concatenate, and this one is an append, other is a merge. So the how it kind of functions is very different. Merging by common key, this is straightforward. Like if you have two data frames, you can use pd.merge df1 df2 on how. So you have inner, outer, left or right of how you want to join or make the type of joins. On is the kind of a key which should be common in both the data frames for the pd.merge to kind of function. Now, all of the different pd mergers are already present, so you can take a look. Okay, let's look at the join method. So join essentially kind of, it's like a merge. Not much of a difference. You'll have almost similar outputs even if you use a merge or a join. So here you simply say, okay, dot join. How you do use a left join and then remove the duplicate. So it's a straightforward thing, merge and join, to be able to create a single data set from multiple data sources where you combine and then have a single data set for all of your data science and analytical work. Okay. Any questions before we move to different useful commands? Also, I'll use the last 10-15 minutes for any Q&A if you have anything. So I'll be around and then able to answer. Okay, I don't see anything. So some other thing, like you can use a sample to get a sample data. You can get a sample something like this. Um, you can do sorting on the data. Simple say sort underscore values, and you'll be able to get sorted data. And you can use an apply function. If you have a function, and you can use apply to kind of apply that function on all of the columns of your data set. So that's how apply works. And it's a very powerful thing. So if you see, okay, this is the data set, dot apply length. So length is going to get applied on this data frame and you're going to get the output. So with that, we kind of complete pandas. And there is something called as Python Dash. This is basically to build interactive dashboards like Tableau. So take a look at this. There is a ton of visualizations that you can do, uh, and there are a lot of dashboards that you can easily build. So take a look at this, and this is the code repository you should all have access to. So this is what we'll use for the entire course. You have k-means, KNN, PCA, time series, segmentation, linear logistic, regression problems, example, data science projects. So you have everything in the code repository, one single stop shop for your entire Capstone project. So take a look at this, get yourself comfortable, and in tomorrow's session we'll start from machine learning. And any questions? Okay, so Any questions before we go ahead? We have last 15 minutes. I'll be around. Please populate the feedback, complete it. Yes, practice a lot. The how much you can practice, only then you'll be able to get that expertise and confidence in programming. So practice a lot. There would be small mistakes in syntaxing. Don't worry too much about syntax. You will learn over time. So practice, get yourself comfortable, know the functions that are available. That will help you to go in the long way. So any last questions? And please submit the feedback meanwhile. Cool. Then thank you so much, everyone. Take care. And I'm still around for 10-15 minutes. Please submit the feedback and I'll be happy to answer any kind of questions you have. Okay. Thank you so much.